So in this video we're going to derive the three main Pythagorean trigonometric identities using these three triangles. Now they're all looking very similar but with one difference. I've just moved around where the side length is 1. The angle theta is in the same place and this angle here is always a right angle. So that's our basics that we need. So what we're going to do, each triangle I'm going to go along and find out which trigonometric identity I can withdraw from each one. So let's start with this one, triangle A. So I've got the hypotenuse is 1 and I've got this angle here theta, but I don't know these two side lengths. So using SOHCAHTOA, let's look at the first one, SOHCAHTOA, sine equals opposite over hypotenuse. So in this case, its opposite is this side, let's call that the opposite, and the hypotenuse in this case is 1. So opposite over 1. Now if I just multiply both sides by this 1 to try and get this 1 over here, I've got sine theta equals the opposite. Let's just call that opposite there. So it doesn't look like a 0. I can see that that looks like a 0. So sine theta equals opposite. So here we've got sine theta. Now looking at the second part, we've got cosine is adjacent over hypotenuse. So cosine theta equals adjacent over hypotenuse. And in this case, adjacent I don't know, but the hypotenuse is 1. So adjacent over 1. So this being my adjacent side. Then bring the 1 over here. Cosine theta equals adjacent. So that's cosine theta. So depending on that angle, that's what the side length will be, and same with this one. So now as it's Pythagorean identity, I can just square these two sides and add them up to get my hypotenuse. So remember Pythagoras Theorem, a squared equals b squared plus c squared. So with these trig identities, I'm only going to use elementary mathematics. So cosine theta is adjacent. So square that one, square that one. So cosine squared theta plus sine squared theta, that is 1. And that is probably the most famous trig identity that we use. So now let's have a look at this one. Now I started off with sine theta, so I'm going to do the same with this one. So triangle B, sine theta, let's use this again. Sine theta is opposite over hypotenuse. I don't need to write that out again, but opposite is 1. And hypotenuse here, we don't know what that is. So I'm going to just put hypotenuse. Okay, now multiply both sides by hypotenuse and divide by sine theta. I can just switch them around. So then I will get hypotenuse equals 1 over sine theta. Now the reciprocal of sine is cosecant theta. So that's cosecant theta. So that is my hypotenuse. So that's cosecant theta. Okay, now what about cosine theta? Could I do that one? I could do that one, but I've already got my hypotenuse. So what I'm going to do is here, I'm going to use tangent. So tangent theta equals opposite over adjacent. So here I've got opposite over adjacent. Opposite over adjacent. So I've got that one given. So 1 over the adjacent. Okay, now if I bring the adjacent here and the tan theta here, I've got my adjacent equals 1 over tan theta. Now the reciprocal of tangent theta is cotangent theta. So basically my adjacent side is cotangent theta. So that's my adjacent, and I've got cotangent theta. Now I've got a representative for each of my sides. So now square these two, add them up, I should get this one. So now I've got cotangent theta squared plus 1, squared is just 1, nothing to do there, equals cosecant squared theta. That is my second trig identity taken care of. Then we've got this one here. So where are we going to start with that one? This time I've got my adjacent one here, so I'm going to need to use that. So I'm going to use cosine equals adjacent over hypotenuse. So cosine theta equals adjacent over hypotenuse. And in this case, it's 1 over the hypotenuse. So I'll just write down that as my hypotenuse. So 1 over hypotenuse. So now switch places with cosine theta and hypotenuse. I've got hypotenuse equals 1 over cosine theta. Well, the reciprocal of cosine is secant. So that is secant theta. And that's my hypotenuse. So let's put that one in there. Okay, right. Now, as I've got this one given to me, to get this one opposite over adjacent, let's use tangent again. So then tangent theta, as is here, opposite over adjacent. So it's this one, opposite, I write that as my opposite, over adjacent, which is 1. Okay, now what have I got here? Tangent theta equals opposite over 1, multiply, bring the 1 over. I've got opposite equals tan theta. So then I can just write that in there as tan theta. Okay, now using my Pythagorean theorem, a squared is b squared plus c squared. I square this, square that, should equal this one squared. So then I've got tan squared theta plus 1 squared, which is just 1, should give me secant squared theta. So let's write that there, just squeeze that in, and there we go. And there's our 3 main trig identities.